Now, if we elaborate the monosaccharides, we see that monosaccharides are actually a simple sugar. They are actually the sugars which cannot be further hydrolyzed. That means they are simple sugars. That means they are formed of only one kind of sugar, and if we will hydrolyze that, they are not hydrolyzed, and we cannot even get many more components out of it, because it is formed of only one component, that is one sugar. So, monosaccharides are the simplest one, they cannot be further hydrolyzed. And if we talk about the molecular formula, this is CH2ON, that means this CH2O, this unit can repeat at several times. And you know, when we see that what kind of functional group they carry, so we see that they may carry an aldehydic group, or they may carry a ketonic group. So, if they carry an aldehydic group, they are called as aldoses, and if they carry a ketonic group, they are called as ketoses. So, and depending upon the number of carbon atoms, that means they can carry a carbon atom ranging from 3 to many. The simplest is the 3 carbon atom sugars, right. So, depending upon that, we name them as triose, hexose, pentose, heptose, just depending upon that how many carbon atoms are present in it. But as I told you, that minimum number of carbon atom that is present in the simplest monosaccharide is 3 carbon sugar, that is glyceraldehyde and dihydroxyacetone. They are the simplest sugar which are containing 3 carbon atoms. As you can say, glyceraldehyde is CH2OH, COHH and CHO. And what kind of sugar it is? Obviously, you see it an aldehydic group, so that means it is aldoses, or this is a aldehydic sugar. The second simplest one is CH2OH, C double bond O, CH2OH, again a 3 carbon sugar, and it is dihydroxyacetone, and as you can see a ketonic group, so it is a member of ketone, that is it is a ketosis, because it contains a ketonic group. So, this is how you are going to classify that, depending upon number of carbon atoms, that what general name you can use for the sugar. Few more examples, few more aldoses like ribose. You know that ribose is a main component of RNA. Ribose sugar is present in a RNA. So, what is the formula? And like it is an aldehydic sugar, as you can see an aldehydic group. So, you see that it is CH2OH containing how many carbon atoms? 1, 2, 3, 4, 5. 5 carbon atoms, and it has aldehydic group OH, H, OH, H, OH, H, and then CH2, again H and OH. CH2OH. So, this is something called as ribose, an important sugar. And likewise, we have glucose, and glucose also you can see an aldehydic group, so it is also a member of aldoses. How many carbon atoms? We know that glucose is represented by C6H12O6. This is what we will see here. It has 6 carbon atoms, 1, 2, 3, 4, 5 and 6, and an aldehydic group. And we have one more sugar, that is fructose, but it is actually a member of ketose, because we see a ketonic group here. How many, its molecular formula is also same, but the arrangement of atom is actually different, because you see that both have same formulas, but it has an aldehydic group and it has a ketonic group. So, how many carbon atoms? Again 1, 2, 3, 4, 5 and 6, but it has a ketonic group. This is called as fructose. Though I have made a straight chain structure, but actually they are a cyclic compound, not a chainless straight chain structure. They are cyclic compounds, but for your convenience, I have just written in a straight chain manner, so that it is easy to learn in this way. And if we talk about the properties of the monosaccharides, we see that they are crystalline in structure. They are crystalline solid, and they are soluble in water. They are sweet in taste, as you all know that sugars taste sweet, and they are optically active because they contain an asymmetric carbon atom. We know that optically active means they can rotate the plane of polarized light, and the condition which is required to be an optically active substance is a asymmetric carbon. So, it possesses that asymmetric carbon, that is why it is optically active. We see that they exhibit normal reactions that you can aldehyde or a ketone show with an alcohol or aldehyde or ketone. So, it shows actually a simple reactions. And you know that as I told you that this is an important part of this chapter, this topic. Glucose is represented by C6H12O6 and fructose is also represented by C6H12O6. But if you get a, like if I tell you that I have C6H12O6, but tell me, prove it, that whether that C6H12O6 is a glucose or a fructose, then how you are going to prove that? So, we have certain tests for that. One is that If we talk about glucose, it is an aldehydic sugar, and if we talk about fructose, it is a ketonic sugar, right. So that means it must be, means it can give a test of aldehydic group and it can give test of ketonic group. So let us see that what kind of test a glucose being an aldehyde can give. So we see that because it has an aldehydic group, so that means it can even get oxidized with mild oxidizing agent. It can even oxidize with mild oxidizing agent like bromine water, like we have bromine water. So what actually what happened here is, suppose I have this thing glucose, the formula is like this, I can just club them up, right. So what happened, we have bromine water, we see that it gets oxidized turning this aldehydic group into a carboxylic group. So it becomes CH2OH, CHOH whole 4 and COOH. That means CH2O turns into a carboxylic acid group. So it can actually decolorize bromine water. Like when bromine water gets decolorized, it proves that oxidation has been taken place, and because it is oxidized in an easy mode, so that means it can act as a reducing agent. Likewise, it can show many other tests also, like it can oxidize the Tolerant reagent also. What is Tolerant reagent, how it is formed? We have AgNO3 mixed with NH4OH and we get AgOH precipitate with NH4NO3. Then we react this AgOH whole twice again with more NH4OH, and as a result we get a Tolerant reagent which is something like this, right. Then what we are going to do is, we are going to put this glucose into a, we will take a test tube, we will add a Tolerant reagent, we will take a glucose in that, and what will happen actually, see this is my sugar, I am going to add a Tolerant reagent, I am writing in an ionic form. So it gets oxidized to a carboxylic group, forming silver, forming NH3 and water. This Ag formed actually form a silver mirror in a test tube. So formation of the silver mirror shows that oxidation has been taken place, and it is a good reducing agent because it can get oxidized even with the mild oxidizing agent. Likewise, it can also give a test of when treated with Fehling solution. We know that Fehling solution is formed of Rochelle salt mixed with copper sulfate. What is Rochelle salt? It is sodium potassium tartrate, right. So when they both are mixed, they form a, firstly the copper hydroxide precipitate is formed, then it dissolves to form a clear blue color solution. Then what we do is, we take a test tube and we add this Fehling solution and glucose into it, and what do we observe actually, what kind of reaction take place? The reaction take place like this is a glucose, we have copper ions here, hydroxide ions here, I am writing in an ionic form. It forms a carboxylic acid, it forms a copper oxide and water. So what happened here, it was of blue color, but here it turns into a reddish color. So formation of this reddish color just indicate that the reaction has taken place, or you can say oxidation of glucose has been done. So as you can see that it contains an aldehydic group, it contains a ketonic group, so that means it is first one of the major difference between them. Second is that you can write the structure. Third, we have certain tests. It can be oxidized with mild oxidizing agent like bromine water. That means it can decolorize bromine water, but it cannot decolorize bromine water. No test with bromine water. And likewise, it shows it can be oxidized with toluene and Fehling, as glucose can be oxidized with toluene and Fehling. So as in the same way, ketone, fructose can also be oxidized with toluene and Fehling. So if somebody asks you about the test, that how you are going to distinguish between glucose and fructose, the main test which you can use is the decolorizing of bromine water. That means the glucose being containing an aldehydic group can decolorize the bromine water, because it can even be oxidized with mild oxidizing agent. But if we talk about fructose, it cannot be oxidized by bromine water. So we say that aldehyde is a best comparatively good reducing agent, and comparatively ketonic is a less reducing character in it, right. So this is what is a test to confirm that whether a given sample is a glucose or a fructose. I think you're clear with monosaccharides now, that monosaccharides are simplest sugar, can be aldoses, can be ketoses. We have few examples. Depending upon number of carbon atoms, we can classify triose, pentose, hexose, heptose, like that, and we have a certain structures also. See, you don't have to get so much into structure, but at least keep a handful of structures with you. That means few structures you should be familiar with. And moreover, you should know that these structures which I have made, they are straight chain, but actually they are cyclic. In a natural, you can say, if we talk about their actual structure, they are cyclic in nature. And likewise, these are the characteristics, and these are the tests for distinguish between glucose and fructose. So this is what is